Okay, this is a continuation about regarding our discussion on data processing and management. Previous lecture we talked about some of the GIS processing tools. We're going to continue with our discussion along those lines. The table of content is very simple in this lecture. We're just going to continue with the tools discussion about GIS, data manipulation, and analysis. Alright, your GIS software should be able to do some basic measurements. And from measurements I'm referring to here, there are two types of measurements commonly required. Is distance calculation, and your distance calculation can be along a straight line distance. For example, if I want a straight line distance from point 1 to point 4, what the GIS system will do is take the coordinates of the point at point 1 and the coordinates of point 4, and using basic Pythagoras theorem and be able to compute what is that distance. So in this case here, this little graphic shows you point 1, and in this case it will be point 4, and using Pythagoras theorem you can compute that straight line distance. Or your GIS should be able to do distance along a particular feature. For example, if this is a road, I want the entire distance from point 1 to point 4, however, not a straight line, but actually following the road. So what the GIS software will be doing is computing that distance, adding it to that distance, and there they go. So the total distance along the path can be from point 1, 2, 3, and 4, or it can be straight line distance between point 1 and 4. And the same formula that they use, that's programming in the software to do this computation. Your GIS should be able to also do is compute, the GIS software should be able to provide a tool to compute area and perimeter calculations. And what it does is use, in order to compute the area, it will use the area computational formula with regard to trapezium. Half of sum of parallel sides multiplied by height, and then be able to compute the area of any shape polygon. Once the polygon is defined by a set of coordinates, of course provided by the coordinate system, it will be able to compute the area of that entire feature. And how it works is actually it will compute this area between this trapezium, and also compute this area, subtract this from that, then compute this area, subtract it from the entire amount. And what it'll do, compute the entire area and subtract it from the entire area, from including the area of interest. So using trapezium rule, this simple formula is programmed into the software, GIS software, and the area for whatever shaped polygon, it will compute the area for it. The perimeter, it will compute the distances along a particular feature, the sides of the feature, and sum them up, and it will give you the perimeter. GIS software should be able to do optimal path selection. For example, a lot of us would have been using, let's say for example, MapQuest or any other online network analysis tool. Put simply, how it works is that you specify an origin and a destination, and what the system will do, the tool will do, is compute the shortest distance. Now, the shortest distance can be with respect to time. It could be with respect to distance, of course. But also, let's say if there was an accident that occurred along this area, the shortest distance is actually going to be along this path here, where the accident occurred, avoiding that to where your destination is going to be. This is the process of using a network database of road and road intersections to select the optimal path based upon specified time and distance. So your road network, which is shown here, is a set of lines. Each one of those lines would have certain attributes associated with it, apart from the addresses on the left-hand side and the right-hand side of the road, but also the speed limit, the quality of the road, the time of which is high traffic, things like that. The more information you would add on to this road network, the better would be your results in terms of optimal path selection. This is an example of what you would do in the GIS software, the QGIS software that you have been practicing using. There is also a tool where you can define its origin and destination, and the system will actually delineate for you the shortest path. Quite simply. Very useful tool. The GIS software should also do some digital terrain analysis, and one of them under the digital terrain analysis, spatial interpolation. The GIS software should be able to interpolate heights between points of known elevation. So if I have a set of spot heights, I want the system, the GIS, to interpolate for me what are the heights between the spot heights, or interpolate for me based upon the spot heights, the contour lines between them. This can be done for any point data, so it doesn't have to be height information alone. It could be temperature, for example, or even looking at population density. You can extend it out to include any point data, and the system will do the spatial interpolation for you. This is done using randomly distributed points data to derive elevation into a regular grid or triangular irregular surface. This is a little diagram of how these points are used to create, to do the interpolation. If I have random points that I would have observed out in the field, or these points can be based upon observations I made on a regular grid out in the field. Using either one of them, I can create or do some interpolation. One of the common interpolation is a triangular network. The system would create a 10 based upon the height information, that these were height points. The most common method of interpolation, the linear interpolation, that is, if I have known points, height information, the system would interpolate between the points, contour lines, or it can be based upon a windowing or filtering capability. Let's look at each one of them. Linear interpolation, if I have, let's say, point data, all right, this is a height, this is a height, this is a height, this is a height, value 10 here, 20. What is the height halfway between them? The system would do the interpolation for you automatically. Or windowing is where the system would use, and this is with respect to raster structure, where the system would have in its tool a window of, for example, a 3x3 filter. What it does, that filter would be using the data, the raster cells or the pixel cells values, and it's just the filter would move across the entire image, getting the data from the cells from which the filter is overlapping or overlaying onto the image. Computing, for example, it could be use all of these outside values of the that fall within the filter and compute from the mean or the standard deviation and apply it to the central pixel. Once it does that, then it'll move on to the next one and do the same thing. Give me the standard deviation or the mean or whatever process you want the filter to do, it will do that for you once it's available in the GIS software. And it will move from one cell to the other, one cell to the other. And when it's done this entire row, it will come down and do the same thing. Go across and then do the entire image. Very useful process or tool is windowing using filters. Contouring is another, as I said before, a set of random points. These points were observed points of heights in the real world, in terrain. And using these random points in the interpolation, the system would create, there are tools to create contour lines based upon the observed points. There are also tools available if I want to create a map, a slope map, all right, or gradient map, or an aspect map. These are tools readily available in your GIS software. These are different views of the surface. If I have a contour line map over my spot heights, I can create slopes, I can create gradient maps, or even aspect maps. Very useful tools. And again, it will create information, derive data that you can incorporate in your GIS application. This is an example of a contours map, topographic map, and using the contour lines, it was extracted, and from the contour lines, each one of those lines was going to have a height above mean sea level. Using this, we can create our 3D model or a digital elevation model. Very simple to do. It looks difficult, but it's very simple. This is a slope map where the system would have a slope tool. Once you have a DEM, the system can generate the slope map. You don't go out in the field to measure slope or observe slope or collect slope information. You collect height information, and from that you would use your GIS system, GIS software, to create a slope map. This is an aspect and gradient map together with your slope map. So this is an aspect map. If I have my, the original DEM, I can use that as input and it create an aspect map. Slope map here showing up. We can have profile curvature map or tangential curvature map. I mean, these are all different ways of viewing your data, your original data, and these are all derived data from your original observed data. Very useful, and as you get more involved into GIS application, you would see how these are actually put into made to good use. Very useful. A common tool available in GIS software is Kriging. It's another interpolation technique in which the surrounding measured values are weighted. So using a set of weight, the system can come up with new surfaces or new 3D models to come up with predicted value of unmeasured locations. So that's based upon the observed data. I would have a certain weight attached to particular points, and it'll come up with unmeasured location. Your GIS software should also be able to do things like sun intensity, calculate based upon the angular slope, which area we're going to have the morning sunshine, and which area is going to be affected by any shadow, things like that. GIS software should also be able to do some watershed analysis, that is the study of water runoff on the landform. Show me the direction in which the water would flow, assuming it does not percolate into the soil, the direction in which water would flow. That will indicate to me where I need to locate my drains, position my drains such that it will efficiently make all the runoff of water to find its way into the design drains. Viewsheds is a study of intervisible points. If I want to put, for example, location of cell towers, these cell towers need to be intervisible. In order to do that, the telecommunication companies would have had to derive viewshed maps. The GIS software should be able to do cross-sections, profiles representing the landform. I want to put a road from point A to point B. Show me the profile between point A and point B. I want to minimize the amount of cut and fill because that's expensive. The GIS software should do things like 3D viewing. If I have a 3D model, I want to see a three-dimensional views of the data. I want to see different perspectives. What is the view from the northeastern part of the study area at a particular height above mean sea level? So many tools available. This is an example of a map showing Cregan, the effect of Cregan, and what it did was actually get some point location of arsenic values, and the area shown up there is high arsenic values in certain areas in Texas area, and also there are high arsenic values using the Cregan method, Cregan tool, to come up identify where these areas are. This map shows sun intensity, where we have certain time of the year, show me the sun intensity in certain areas, and as you move away, obviously on this side here, on the lower southwestern U.S., the sun intensity is high, as opposed to the northeastern section of the U.S. A very useful map in terms of if I'm looking at sun intensity, and this will be related back to type of vegetation, and also looking at drought and certain things like that. This slide shows you an example of watershed analysis that some GIS would be able to provide tools to do. Here you see a 3D model of the terrain with the overlaid drainage network. So if I have a drop of water that falls at the top of this peak, this is the part it will follow until it reaches the main river down upon which it's going to flow out. So very useful in terms of identifying my drainage basin. And in order to do drainage basin, determine drainage basin area, that will affect later on if I have to put in drainage network. We need to know how much water is actually going to flow into that new development where I have to provide drainage network. At the bottom of that diagram, the 3D model, we have drainage basin and flow accumulation risk. They were able to, for this particular area, identify the various drainage basin, and also the high risk in terms of flooded areas. Very useful. This is an area in India. And here on your right is a drainage basin in Florida. So using the tools available in GIS, they can determine various drainage basin in different countries, in different areas. Very useful in terms of, let's say if I want to put in a dam, where I need to put a particular dam, how much of the area is going to be affected later on, or even before the dam. If I have a settlement up further upstream, how much is going to be affected. This is an example for viewshed that I talked about early on, where we have, for example, the area showed up in the dark red is not visible. So these are not visible from this location here. This is my location. If I was to stand there, the area show up in green would be the area I can see directly. And the other areas, because of the topography, It's difficult to see here because we're looking at a 2D environment, but if you stand here, the GIS system would be able to identify, okay, I can see if I'm putting up cell towers, if I put one here, then I can put another one here because they would be intervisible. If I have a new settlement in this area here, then I need to, obviously I kind of put up a cell tower here that will communicate with it in this direction, but if I go at this location, I'll have another map showing me the view shed where I can put an additional cell tower so that it will provide coverage for the new settlement. Very useful in terms of analysis of intervisible points. Here you see cross-section, an example of cross-section. If I have a GIS system that has the tools of creating profiles or cross-sections, draw for me the cross-section from this point to point A, let's say, and point B. And what the system will do is create that cross-section very quickly, and it shows immediately that this area here is very mountainous, and it goes down to a very gentle slope. So it goes up, and then it fluctuates a bit and comes back down. Very useful tool. Your GIS should also provide tools to do 3D viewing. A lot of the GIS application is heading in that direction, where users are wanting to see their data in a 3D environment. For example, Google Earth, in urban areas, you have high-rise buildings being displayed in a GIS environment. Similarly, you want a GIS system where, for example, here, you have an urban area, on this map, urban area, and I can view the different perspective. Instead of looking directly from above, I want to look at the city area from a particular angle, and I can select buildings, and the attribute table will show up in the GIS software. Very useful application if I'm looking at homeland security. Where do I need to put security cameras? If it's along the coast and I have the patrol, the Coast Guard, show me the areas that they can see, and also show me the areas that they cannot see where there is need for additional security cameras. In this map, you see another 3D model of a terrain, and you see it also with raster data overlaid. The area, the yellow and red areas is raster structure data. And also you have 3D images included on, there's a boat. And also draped onto the surface, you have vector data, which is your red line for your road networks. Very useful application, and you can rotate this image, look at it from different perspectives, just like how this map shows you different perspectives. The GIS software should also provide the ability to do some statistical analysis. I mean, it's not just only looking at the mean and standard deviation, but also do things, the regression and correlation. Some even do things like hypothesis testing. Okay, very useful in terms of getting as much information from your observed data and to predicting new data. All right, projecting what it will be like in the future. Statistical analysis, this concerns with the general aggregation of data according to the well-defined statistical procedures in order to provide the user with a better perspective on the collection of data. A lot of the people who are into collecting numerical data make use of GIS to look at their data, not just to create pie charts and bar charts, bar graph, but also be able to attach that to some map and be able to look at the spatial relationship and do a lot of inference in terms of the spatial data, the final map that they would produce. This is an example of statistical analysis where you have revenue per customer by distance. How much people are spending this particular customer, how much are they spending at a particular urban area or particular store. they are actually buying a lot, spending a lot. We have one or two of them, but a large majority of the people who are spending is actually located in this area, because I have a the red indicate large spending. All right, so very useful map in terms of doing some statistical analysis and displaying that information. Very useful. The GIS software should be able to do some attribute analysis in terms of the functionality of it. It should be able to edit your attribute table, add columns, add rows, be able to update existing data, change names of certain certain attributes in your attribute table, delete or remove data, delete a column, add a column. Your GIS software should also have tools to do things, attribute query functions, to build my query, my SQL query using the mathematical operators. It should be able to provide those tools. Very, very useful, because that's the only way your GIS can answer the questions that your customers or your clients want to be answered. This is an example of attribute analysis functions where the system is able to define queries, select from certain areas, define a query, and report back to me what's the final result. So these are the number of tools available. Based upon my attribute table has a number of attribute information. I want the system to define the query. I'm going to define the query using the tools, and then run the query, and the maps will come back with the answers to the questions via the query. All right, so your query helps the system to define the question, and the answer will come back is going to be the answers that your client or your customers want to be answered. Very useful application, or very useful tool, and it's commonly used by all GIS software. Okay, this concludes our discussion regarding data processing. Please download the PowerPoint notes presentation, go over the material, make sure you understand it. If you don't understand certain parts, rerun the audio for the explanation, and we'll continue with the next lecture.